NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
On December 25th, 2021, the James Webb Space Telescope, JWST, embarked on its long-awaited mission. Blasting off from Earth and making its way through the darkness of space, Webb was more than just a scientific instrument. It was the culmination of decades of research, hope, and determination. Touted as the successor to Hubble, Webb carried the dreams of astronomers, engineers, and curious minds across the globe. Its promise was clear: to push the boundaries of our knowledge, to peer deeper in time than any telescope before, and to answer fundamental questions about how the universe began and what it contains. For years, anticipation built with every delay, every cost overrun, and every whispered fear that the mission might never leave the ground. And yet, against the odds, Webb unfolded its golden mirrors and bloomed in the void like a cosmic flower, perfectly executing one of the most complex deployments in space history. From its orbit at the L2 Lagrange point, 1.5 million kilometers away, it became humanity's newest eye on the universe. Webb represents a leap forward in technology and ambition. Harnessing the infrared spectrum, the telescope can penetrate cosmic dust clouds, illuminate the birthplaces of stars, and detect signals from distant galaxies formed just a few 100 million years after the Big Bang. Its instruments are so sensitive, they can pick up the faint chemical fingerprints of exoplanet atmospheres light years away, hints perhaps of worlds that could harbor life. The launch of JWST was not just a scientific milestone, but a moment of global fascination and collective wonder, signaling a new era in humanity's cosmic exploration. For the first time, we had a tool capable of looking both backward in time and outward across unimaginable distances, weaving together the earliest chapters of cosmic history with the mysteries of worlds orbiting distant suns. And yet, despite the monumental expectations resting on its golden mirrors, rumors began circulating soon after its early operations. Stories emerged, claiming that NASA had abruptly halted the telescope's activities after sensitive observations of Mercury, the innermost planet in our solar system. Allegations flourished online, suggesting NASA's instruments had captured shocking new data. So unusual, it was said, that the agency had chosen secrecy over disclosure. What, if anything, truly transpired? How do these stories align with what is actually possible, both scientifically and technologically, for the Webb telescope and our current understanding of Mercury? Mercury, a planet of extremes. Mercury, the smallest and nearest planet to the Sun, has long fascinated planetary scientists, despite being one of the least explored planets in our solar system. Its proximity to the Sun makes it a difficult target for spacecraft, but its extremes make it one of the most intriguing. Mercury's harsh surface is marked by gigantic temperature swings, ranging from nighttime lows nearing -180 degrees Celsius to daytime highs above 400 degrees Celsius, and battered by continual exposure to solar wind and radiation. Unlike Earth or Venus, it has no thick atmosphere to redistribute heat or shield it from the Sun's relentless intensity. Instead, its thin exosphere, composed mainly of sodium, oxygen, and trace elements, offers little more than a ghostly haze that barely clings to the surface. The exploration of Mercury is a saga in itself. It was first visited by Mariner 10 in the 1970s, which managed only fleeting flybys that revealed tantalizing glimpses of a world scarred by craters and cliffs. Decades later, NASA's Messenger mission finally unlocked more of its secrets, orbiting the planet between 2011 and 2015. Messenger delivered breathtaking images and groundbreaking scientific revelations, Mercury's enormous iron-rich core, which dominates its interior, its shrinking crust, evidenced by vast fault scarps that stretch for hundreds of kilometers, and mysterious bright features known as hollows, unexpected, shallow depressions that seem to form in ways scientists still struggle to fully explain. These discoveries painted a picture of a planet both familiar and alien. On one hand, Mercury shares the battered, cratered look of our moon. On the other, it hides mysteries no other planet exhibits: enigmatic deposits at its poles, strange magnetic field behavior, and a density that suggests an unusual origin story. Did Mercury once lose much of its mantle in a catastrophic impact? Did it form under conditions unlike those of its planetary siblings? These questions continue to drive research today. Most scientists came to regard Mercury as a relatively quiet planet, geologically speaking. It is not thought to have active volcanoes, shifting plates, or a thick, dynamic atmosphere. Its history is one of early violence, marked by massive impacts, ancient volcanism, and possible episodes where the sun's immense energy stripped away much of its outer layers. And yet hints of past dynamism remain. The fault scarps still creeping across its surface, the polar ices improbably surviving in the shadows, and the curious hollows that suggest Mercury may not be as lifeless as once assumed. Before we continue, make sure to subscribe to the channel so you never miss deep dives into the solar system's strangest worlds. From Mercury's mysteries to the farthest galaxies Webb is unveiling. Diamonds or illusions, a look at real possibilities. Among the more persistent rumors is the suggestion that the Webb telescope detected vast deposits of diamond or other exotic crystalline materials on Mercury. Some speculative accounts have claimed NASA's rapid shutdown and silence were prompted by such a discovery. But what do science and current knowledge allow us to believe? On Earth, diamonds are formed deep below the surface, at high pressures and temperatures, where carbon atoms rearrange in a tight, crystalline structure. These conditions exist due to tectonic and volcanic activity, which Mercury largely lacks. The planet's formation and volcanic history do suggest sudden, violent changes, but whether natural diamond formation could occur near Mercury's surface is, at best, highly speculative and unsupported by direct evidence. The Messenger mission did reveal dark patches consisting of carbon-rich material on Mercury. Some scientists hypothesize that this could include graphite, and models have considered whether past impact events might have created high-pressure conditions that in rare circumstances could cause diamond formation. However, no confirmed detections of diamond on Mercury have been made. No peer-reviewed publications support this, and no infrared telescope, Webb included, is currently capable of such a detection without extremely specific conditions. Thus, while Mercury's history invites creative hypotheses, the leap to a secret cache of surface diamonds visible to Webb simply isn't substantiated by available science or any confirmed data. What Webb can and cannot observe. The technological brilliance of the James Webb Space Telescope lies in its position and instruments, but these also define its limitations, especially in relation to Mercury. Webb is stationed at the second Sun-Earth Lagrange point, L2, about 1.5 million kilometers from Earth. Its instruments are designed to be shielded from both sunlight and the heat of Earth and Moon. Pointing JWST even close to the Sun would not only risk damaging its precious optics and sensitive detectors, but is specifically prohibited except under rigorously controlled conditions. For this reason, Webb is generally unable to observe inner solar system objects like Mercury, Venus, and Earth itself. NASA documentation is explicit. The James Webb Space Telescope can't see Earth, Venus, or Mercury, and it's all to do with its location, its orbit, and its instruments. Even the technical manuals warn against orienting the telescope anywhere near the direct glare of the sun. Doing so would overwhelm its instruments and defeat the cooling system that keeps Webb functioning at cryogenic temperatures. Rumors about Webb's secret Mercury observations do not align with the engineering reality. Any direct observation of Mercury by JWST would be a highly risky, tightly controlled, and publicized event, not a clandestine maneuver. There are no credible reports in peer-reviewed science or agency documentation indicating Webb has been pointed toward Mercury, much less that it was abruptly shut down to conceal data. The shutting down of Webb, separating fact from speculation. From time to time, Webb's instruments undergo scheduled pauses, recalibrations, or safe mode protocols, standard practice for such a sensitive observatory. Minor technical issues are addressed through well-understood procedures, often publicly documented in mission logs and agency updates. However, assertions that the James Webb Telescope was shut down due to astonishing findings on Mercury are, simply put, not supported by any factual source. Instead, the telescope has continued its primary mission, capturing the faint glow of the earliest galaxies, mapping the atmospheres of distant planets, exoplanets, and announcing discoveries such as new moons around Uranus. None of these involve direct surveillance of Mercury, which remains far too close to the Sun for Webb's field of view. The nature of Webb's observations and timelines of safe modes or pauses are publicly available. While the telescope, like any spacecraft, occasionally hits brief operational snags or requires temporary shutdowns for safety reasons, these have never been linked to Mercury-related findings, let alone sensational claims of hidden planetary secrets. Mercury's real mysteries. Mercury remains a place of genuine scientific mystery, but for reasons grounded more firmly in observation and theory than in unintended revelations by Webb. Some of the planet's enigmatic features include the presence of water ice. Despite Mercury's proximity to the Sun, radar observations have confirmed that permanently shadowed craters at the poles harbor frozen water, preserved at temperatures below -170 degrees Celsius. Strange hollows. These shallow, irregular depressions, first detected by MESSENGER, have an unusual brightness and bluish hue. Their formation likely involves the interaction of the planet's surface with harsh radiation, potentially causing volatile materials to sublimate. But the process and composition remain under debate. Unusual core size. Mercury's core makes up about 85% of its radius, by far the largest proportion in any rocky planet. The reason for this, and how much of it is molten today, is still a subject of scientific research. Past geological activity. Fault scarps crisscross the surface, some stretching for hundreds of kilometers, indicating Mercury's crust has shrunk as its interior cooled over billions of years. Whether there are subtle hints of lingering volcanic or tectonic processes is still being investigated. The true promise of Webb and of open science. While Webb cannot and does not observe Mercury directly, its capabilities continue to transform our understanding of the wider universe. For instance, its recent work supporting new discoveries around distant planets like Uranus, uncovering new moons, and helping to characterize planetary atmospheres demonstrates the kind of breakthrough possible with world-class infrared astronomy. The spirit of scientific discovery is rooted in transparency and public engagement. NASA's tradition is to share findings soon after validation, welcoming both enthusiasm and scrutiny from the global scientific community and the public. Speculation fueled by secrecy or conjecture often misses the real drama, the painstaking, step-by-step process by which human knowledge expands. How the stories grew. The emergence of viral online stories about Webb's involvement with Mercury likely comes from a mix of wishful thinking, the lure of hidden knowledge, and misunderstandings of how the telescope works. It is not uncommon for creative imaginations to run with snippets of real science. Mercury's carbon deposits, Webb's remarkable sensitivity, the cryptic wording of technical bulletins, and inflate them into dramatic tales. Compounding this, the delay between dramatic front-page discoveries, galaxies at record distances, atmospheric signatures on giant exoplanets, or images of Uranus's new moons, and the more incremental technical updates about Webb's day-to-day operations creates an opening for rumor and fiction to flourish. Mercury's surface likely contains intriguing materials, various forms of carbon, impact-generated compounds, and maybe even rare mineral structures, but no diamond fields, alien construction, or game-changing secrets have been verified or reported by NASA or the Webb science teams. What's next for Mercury and planetary science? Even if Webb can't train its gaze on Mercury, planetary science presses on from multiple directions. The European-Japanese BepiColombo mission, now en route, will enter Mercury orbit in 2025, carrying advanced sensors to further probe the planet's magnetosphere, surface chemistry, and potential for ongoing geological change. This mission, along with continued reanalysis of decades of Earth-based and spacecraft observations, promises to bring new clarity to Mercury's perplexing features. Science advances by asking hard questions and following the evidence wherever it leads. Sometimes, the absence of a headline-making discovery is itself revealing, reminding us of the immense challenge involved in gathering and interpreting data from worlds scorched by the sun or cloaked in cosmic darkness. Speculation about Mercury's hidden riches and the strategic concealment of cosmic resources reveals something deeper about our times, a growing awareness that the universe might contain not only scientific wonders, but also profound ethical and political dilemmas. If valuable materials, be they diamonds or anything else, are discovered elsewhere in the solar system, humanity will face complex choices about exploration, stewardship, and the sharing of benefits. International space law already grapples with questions about the ownership of extraterrestrial resources, the protection of pristine environments, and the responsibilities of states and private actors. Misinformation or exaggeration can cloud the debate, distracting from real challenges and opportunities facing the next generation of exploration. Conclusion: moving toward new discoveries. With clarity, Webb's launch, its discoveries to date, and humanity's persistent urge to understand worlds like Mercury do not need embellishment to be inspiring. The reality that innovation, patience, and open debate produce real knowledge carries a different kind of wonder. Mercury still guards its secrets, but the process by which we seek them is grounded in shared evidence and ongoing international cooperation. Future missions, such as BepiColombo, continuing analysis of messenger data, and perhaps someday, new technologies able to brave Mercury's heat with infrared precision, will teach us more. Webb, meanwhile, continues to refocus on the distant reaches of the cosmos, extending humanity's reach to the very dawn of stars. As the journey continues, let's remember that the greatest revelations need no cloak of secrecy or sensational headlines. They need clear eyes, open minds, and a commitment to letting the evidence lead the way. The universe abounds with mysteries, and each mission brings us closer to illuminating them. Not through rumor or drama, but through discovery, reason, and shared curiosity. In the end, every scientific pause, recalibration, or redirection, even the ones that invite rumors, are steps in a process far larger than any individual finding. They are reminders of both the difficulty and the promise of exploring a universe that is always a little stranger and a lot more beautiful than we dared to expect. As we look to the future of planetary science, whether aimed at Mercury's harsh daylight or the faint glow of a distant galaxy, we do so as a species, united by the quest for truth and the awe of what awaits. Keep looking up, keep questioning. The cosmos has stories left to tell, and through the lens of science, we are only just beginning to listen.